Class, and welcome to your first video on solving quadratic equations. This is part 1, and we're going to be solving quadratic equations by graphing in this video. We're actually going to have 4 different videos for this lesson. Part 1 is solving quadratic equations by graphing. Part 2 will be factoring. Part 3 will be the quadratic formula. And part 4 will be solving quadratic equations that have complex solutions. So our learning target for today is I can identify real solutions of quadratic equations by graphing. And before we get into our first example, we want to talk about these key words. What is a solution to a quadratic equation? I've mentioned all year that there are 4 words in reference to quadratic equations, or really any polynomial equation, that generally mean the same thing. The word solution, or the word zero, the word x-intercept, or the word root, all means to find the same exact point or points on a graph. When we are solving quadratic equations by graphing, since we're going to be viewing a graph, we're going to be focusing on the word x-intercept for our solutions. So we're going to be graphing the function, finding the x-intercepts, and then naming the solutions from that. These x-intercepts, I will also make a note, and please write this in your notes, that are x-intercepts are real solutions of a quadratic equation. Real versus non-real or imaginary. Okay, so in example 1, it says, what are the real solutions of the quadratic equation? The first thing we need to do is graph the function. And for time's sake, we're going to pause the video here and graph on our graphing calculators. So here's a sketch of the graph that I looked at on my calculator. I noticed that I have 2 places where this graph is actually touching the x-axis. So there are 2 x-intercepts. So one x-intercept is at positive 4, and the other x-intercept is at negative 6. So we would say that there are 2 real solutions to this quadratic equation, and the 2 solutions are negative 6 and positive 4. Some different ways we could see the solutions written. We could say x equals negative 6 and 4, or we could see a solution set of negative 6 and 4. Okay, in example 2, we're going to do the same steps. It says, what are the real solutions for the quadratic equation? Again, we want to graph this on our calculator. However, if you'll notice, this equation is not in standard form. And before we graph on the calculator, we have to have the equation set equal to 0. So, to begin, I'm going to add a 4 on both sides of this equation so that I get a 0 on the right-hand side. Rewriting this as x squared minus 4x plus 4. Once the equation is set equal to 0, this part that I'm underlining in green can be input into the calculator to examine the graph. So pause the video now and examine the graph to find the real solutions. So here's my sketch of what I see on my graph. This particular quadratic equation, or graph, only is touching the x-axis at one point at its vertex, and that is at positive 2 on the x-axis. So we would say that it only has one real solution, because it only has one x-intercept. Now, that x-intercept is called a double root, or sometimes called a double zero. Anytime there's only one answer, one real solution, we call that a double root or a double zero. So the ways we could write the answer is x equals 2, or as a solution set of 2. Okay, so example 3 says, what are the real solutions of the quadratic equation? Again, we see that this particular equation is not set equal to 0, so our first step is going to be to subtract a 15 on both sides so that we can put this into standard form. So we're going to set it equal to 0. 2x squared plus 7x minus 15 equals 0. And if we go to our calculator and graph this, we're going to examine our graph to find our real solutions. So pause the video now, graph it on your calculator, please. So when we graphed this, we found zeros at 1.5 and at negative 5. So those are the x-intercepts. So this looks like a sketch of our graph. So our solutions, or our real solutions, we could say our x equals negative 5 and 1.5, or we could see that written as an answer set of negative 5 and 1.5. So when we look at our example 4, again, we're asked to find the real solutions, which are going to be the x-intercepts of the graph of this quadratic equation. We must begin by setting the quadratic equation equal to 0. So we need to subtract 2x on both sides of the equation, leaving us with a 0 on the right side and x squared. Let's go with descending order. Let's put the minus 2x in front of the minus 8 so that our terms are in standard form, ax squared plus bx plus c. Now, input this into your calculator, graph it, sketch a graph on your paper, and then let's talk about the real solutions. Pause the video. So it should be pretty clear that this one is crossing through the x-axis at positive 4, and then again at negative 2. So our solutions are x equals negative 2 and x equals 4, or the solution set, negative 2 and 4. Example 5 is really similar to example 4, but again we see that we need to set the problem equal to 0 in order to graph it. So we're going to subtract 2x from both sides again. So rewriting this one, it would be negative x squared minus 2x minus 8 equals 0. This time we would know before we ever graph this that the negative in front is going to make this particular parabola frown. If you go back to the previous problem, we had x squared minus 2x minus 8. Here we have negative x squared minus 2x minus 8. So it is, in essence, the same parabola, but it's a reflection of that parabola. It's been flipped from a smile to a frown. So take a moment, graph this, and decide what you think that the real solutions are. Pause the video. So here's a sketch that I've created of this graph. And the thing that I want you to pay particular attention to is that here is my x-axis. And this parabola does not go through it. Not all parabolas are going to go through the x-axis. So when a parabola does not cross through the x-axis, we would say that there are no real solutions. We will not say that there's no solution. There are indeed solutions to this quadratic equation. However, the solutions that we would have to find here involve imaginary numbers. They're not real solutions. So this is what I need you to take away. Real solutions are the x-intercepts of the graph. If there are no x-intercepts, then there are no real solutions. There are solutions. They are just going to be imaginary solutions. So again, we'll say this particular parabola does not go through the x-axis. There are no x-intercepts, so we'll say there are no real solutions. In today's lesson, we're not ready to calculate an imaginary solution, but we will be calculating that before we take our next test. So I hope this video has helped you to understand how you can identify real solutions of a quadratic equation by graphing. Real solutions, again, the key idea here is that real solutions are x-intercepts of the graph. Good luck with your assignment.